Hello everyone. In the last video, we talked at length about the revolutionary concept of levels of abstraction, which is a concept of filling the large gap between problem and electrons by grouping together similar activities into a layer to bring together people working in specific domains, hence increasing productivity. In this video, we talk about technology trends that has impacted the way AI is transforming our ways of life. But before moving ahead, just some mop-up information regarding programming languages, historical evolution of languages. During the period 1940 to 1965, this was the age called as dawn of computing. Some legendary programming languages like Lisp, BASIC, Fortran revolutionized scientific computing and business applications. From 1965 to mid 75, we had structured languages like Pascal and C were very powerful languages at that time. This was the age of structured languages, also called procedural languages. As C is dubbed as the mother of all languages, but these languages lack object-oriented aspects necessary for modularity. From 75 till 95, this was the age of object-oriented languages. The most prominent are C++, which is an extension of C meant for object-oriented programming. MATLAB provides a powerful environment to computer scientists and engineers. We had Python, emphasized on readability and versatility due to its high-level aspects, has undisputedly become the king of AI. Then we have JavaScript, has become the backbone of web until this date. Later onwards, some modern languages were introduced like Go and Rust, Swift, Dart, and Kotlin. These languages were introduced for scalability, for cloud computing, and safety critical systems. Swift is Apple's ecosystem standards. Why this evolution matters, or what are the driving forces behind this evolution? At the core of it, we have performance versus abstraction. From low-level assembly to high-level, for example, Python. Performance versus abstraction is when performance is traded with abstraction. As you move farther from the machine, farther from the hardware, you are gaining flexibility at the top. Languages like Python, like Java, etc. You are gaining huge flexibility. As you're moving towards the hardware, you are gaining performance at the cost of uh, flexibility. Okay, so performance is traded with abstraction, which is why modern AI systems often combine both the worlds to harness their advantages. For example, Python is mixed, combined with C++ for performance gains, and with assembly for even more performance gains, so especially for the code in your program that takes much of the execution time of the processors. So these are implemented in assembly in a mixed form. Then you have expert systems like Lisp are used for specific niche areas. So big systems would have a mixture of high-level and low-level languages. Another driving force is paradigm shift. So we have moved from procedural language to object-oriented languages to functional and concurrent programming. Concurrency refers to the ability of programs to handle multiple tasks at the same time using multiple threads within a single process. Okay, and then we have industry demands. Since the advent of World Wide Web, the demand for web are rising. And JavaScript is undisputedly leading the web domain. Then we have AI, industry demands, AI, adopting AI for automation and intelligent decision making. And Python, as we said, is the king in this domain. And then we have mobile applications. In this age of mobiles, mobile applications had a great boom. So we have languages like Swift and Kotlin that are the best choices for mobile apps. What comes next? In this age, we have AI assisted coding. Microsoft provides Copilot, Gemini 2.5, best at debugging programs, has a large token capacity to take into account complex context. We have Anthropic's Cloudy, some call it Cloudy. 3.5 and 7 are some things that are available for free. So, having said that, let's dive into our today's agenda. The first trend that we are going to talk about is Moore's Law. Let's have a quick glance into 120 years of Moore's Law. As we move along the line, notice the growth in number of computations. It has reached to 1 billion computations per second per constant dollar. So essentially, technology is refining, performance is increasing, while the cost is decreasing. Moore's law is the top-notch law that has driven the technology curve until this date. However, now it is in a transition state towards new technologies. Some even would argue that it's dead. That is not, however, our concern here. We are interested in transistor-based machines. The transistor was invented and successfully demonstrated in 1947, which is a semiconductor device having three terminals to connect to circuits. One terminal is used as a control switch to switch on and off these devices. Essentially, it's a switch, and we have billions and billions of these switches in our machines today that are controlled through logic in our programs. However, since its inception in 1947, these devices were new and relatively unproven technology. Therefore, technologies had to rely on vacuum tubes in this era until it found use in computers in the era of 1960 and 70s. And later, these devices were packaged into integrated circuits. And going further, we had the very large scale integrated circuits. In 1971, a little bit over 1971, all the components of a processor were packaged into a single IC called microprocessor. This was the time when the transistor technology was enabling computer architecture. And Gordon Moore predicted, based on growth of transistors due to refinements in fabrication technology, resulted in smaller, cheaper, and more efficient devices. Gordon Moore, co-founder of uh, Intel, predicted in 1965 that the transistor density of semiconductor chips would double roughly every 18 months. And this trend, if you look at the trend, you would notice that in 1965, he predicted that the transistor density of semiconductor chips would double every 18 months. If you notice in 1975 and 1995, the number of transistors has increased from 10K to more than 10 million transistors. So microprocessors have become smaller, denser, and more powerful. If you project this initial curve until 2020, we would notice that the curve follows the trend by reaching around 2.5 billion transistors in 2010 and 2011. If we project this trend further until 2020, we would not be disappointed either. And notice that in mere 10 years, from 2010 to 2020, the density of transistors have increased from a billion transistors to 50 billion transistors. This staggering amount of sheer power has enabled the kind of AI systems that we all use day in and day out, which in the 90s could only be a dream. This trend of evolution of powerful machines were not in isolation, as growth in transistor density has also enabled increase in software complexity. Just to give you an idea of this complexity, here are some legendary applications and systems that we used then, and some are even used today, but more powerful and efficient. You can follow the source and witness yourself the jaw-opening statistics of modern systems that we use today. Why does this trend matters? Well, maintenance burden, more code is equal to high bug risks. And then there are problems of security loopholes. For example, that is the reason why Office 2013 required rigorous patches. Connecting this with the high level object oriented trends, it does make a lot of sense how these object oriented trend can exploit modularity to reduce debugging pain and managing millions of lines of code. Bell's law by Gordon Bell is another law that we are going to talk about. This is another trend of device diversity, which states that new computer class would surface every decade. Key trends driving this evolution. Number one, miniaturization from room-sized machines owned by governments and organizations to pocket-sized devices. Now the ratio of computers per person has grown from 1 to million to 1,000 to 1. So every person is in excess of thousands of devices. This is because when you request a page, for example, youtube.com, your request has to pass through many switches and routers and ISPs, internet service providers, and has to cross Atlantic Ocean and until it reaches the server and fetches your request and comes back through the same number of devices and delivers the page that you requested for. The second trend driving this evolution is connectivity. The rise of internet and wireless technologies enabling Internet of Things. The third trend driving this evolution is specialization. Specializations are devices tailored for specific tasks, such as fitness trackers, smart speakers, smart watches, etc. There is a further uh, shift towards wearable implants, bio-integrated devices. These are bio-integrated devices. And then we have ambient computing. These are smart environments, also called ubiquitous or invisible technology. And then we have edge AI, localized machine learning for real-time decision making. Uh, these are uh, these are the hot trends that is envisaged that vindicates device diversity. This is another slide that begs a few minutes of your life. Global internet adoption, internet users versus the total population. In 1975, ARPANET, owned by the US military, were able to connect 255 computers. In 1990, when HTTP was introduced, Hypertext Transfer Protocol was introduced, all of a sudden, people started to see the internet. But the internet was not accessible to many. In 1995, we had the WWW, World Wide Web, where commercial ISPs launched dial-ups, and more and more users were attracted towards the internet. During the 2000 and 2010, a boom in social media platforms like the Facebook, the YouTube, Twitter, WhatsApp, and Instagram. The advent of these platforms have connected more and more people to the internet. This can be seen from the fact that in 2005, the year when YouTube was introduced, 1 billion people got connected to the internet. So 1 billion people were using the internet, which roughly forms 13% of the population, of the total population. This trend has quadrupled in 10 years, and in the last 10 years has taken the internet users from 1 billion to 5.4 billion users, which amounts to 70% of the total population. The projected trend shows approximately 7 billion internet users, which accounts for around 85% of the population. 85% penetration of internet users. Just to give you some statistics on YouTube video growth. So as you can see, the growth trend, we have around 5 billion videos, 5 billion videos on the YouTube today. Okay, and just to give you a trend, jaw opening statistics, we have 500 hours per minute, which roughly accounts to around 6 hours of video per second. So every second, 6 hours of video is being uploaded to the YouTube. Per minute is 500 hours. Per hour, we have 30,000 hours. And per day, 720,000 hours. Per week, 5.04 million hours, 21.6 million hours per month, and 262.8 million hours per year. That is amazing, really. And the trend of Twitter, you can see that the daily use is being increased to a level where the engagements as of November 2022 statistics, daily active users worldwide amounts to around 250 million, who are responsible for generating 500 million tweets per day, which makes it 350,000 tweets per minute and 200 billion tweets per year. That's simply amazing. This staggering amount of data cannot be handled manually. This is where AI comes into play, which is the topic of our next video. We will have a comprehensive introduction into AI in the next video. Just a little announcement, if you haven't subscribed yet, don't forget to subscribe, and also don't forget to click the bell icon for new video notifications. I'll see you soon. Stay tuned.